Hello everyone, welcome to another exciting math problem in geometry, especially involve the Pythagorean theorem, a perfect challenge for beginners. Here is the problem. Find the area of the triangle ABC with AB square equals 74, BC square equals 116, and CA square equals to 370. Before we uncover the solution, I encourage you to hit the pause button, grab your pen and paper, and give it your best shot. When you're ready, feel free to share your answers in the comments. Then we explore the solution together. Let's get started. We will provide two different methods for this problem. Firstly, AB square plus BC square is not equal to CA square. So triangle ABC is not a right angle triangle. Since the sum of the square of the two sides is less than the square of the third side, we know that triangle ABC is an obtuse triangle. Using this information, we obtain the length of the three sides of the triangle. This reminds us to the Theorem formula, which involves half of perimeter. However, the value in this case involves some offset, which may not be easily simplified. So we decided not to use this method, although it is a valid approach and possible to use it to get the answer. Instead, using the condition, we construct the point B on AC such that BD is perpendicular to AC. Let AD be P, DC be Q, and BD be H. Then P plus Q is square root of 370. Now, apply the Pythagorean theorem to the right angle triangles ABD and ACD. We get P square plus H square equals 74 and Q square plus H square equals 116. Label the equations accordingly. Consider equation 3 minus equation 2. We get Q square minus P square equals 42. Factorizing the left-hand side of the equation gives Q plus P times Q minus P. As Q plus P is the square root of 370, hence Q minus P is 42 over the square root of 370. Next, consider equation 1 minus equation 4. After careful calculation, we obtain P equals 164 over the square root of 370. Then consider equation 2 and calculate it carefully. We get H equals 22 over square root of 370. Finally, the area of the triangle ABC is half of the base times height. By substituting the values, the answer is 11. What a nice and unexpected answer. And this concludes method 1. Now, let's move on to method 2. Some of you may be sensitive to numbers and notice that each of the numbers 74, 116, and 370 is a sum of two squares. In particular, 74 is 5 square plus 7 square, 116 is 4 square plus 10 square, and 370 is 9 square plus 17 square. Not only that, there is a nice pattern here. Can you recognize it? Yes, you are right. 5 plus 4 is 9 and 7 plus 10 is 17. But wait, what does it mean? With this information, we can actually construct a rectangle of dimensions 17 by 9, cut this rectangle into a few portions as shown. Then we see that the triangle ABC can be found inside this rectangle. In particular, the triangle ABC can be obtained from the half of the rectangle minus the smaller rectangle of dimensions 7 by 4 and two right angle triangles as shown. So, the area of triangle ABC is 11, which is of course the same as method 1. While we have successfully solved the problem, it's always beneficial to practice what you have learned. Using the similar method as shown just now, I believe that you are able to solve the following question. Feel free to try it and share your answer in the comments. That concludes today's lesson. I hope you enjoyed the video and stay tuned for more exciting math challenge in the future. Until next time, take care and bye-bye.